In section 10.3, we continue to look at displaying data with different kinds of graphs. Basically, in this section, we focus on line graphs and scatter plots, and then continue to look at all the graphs that we did in the last lesson. Please refer to page 564 through 571. From your textbook. Also, the video lecture and the PowerPoint are excellent for my math lab in this lesson. I don't use these too often, but this is one section that I think that they are very good. And so I want to show you how to get those because we're not going to do a lot of notes from here. I am going to go through the PowerPoint with you, and then I ask that you watch the video lecture. When you're in my math lab, you can go to Multimedia Library to find that. You'll go to Chapter 10, Section 10.3, and you can look at the video lecture and the PowerPoint, Find Now, and it's going to pull up the video lecture and the PowerPoint. And so what I'll do now with you is I'm going to go through the PowerPoint, and then you can watch the video lecture on your own, and then you should be ready to complete the homework in my math lab. Let me get this where we can see it pretty well. Okay, so the first slide in this PowerPoint says that students should be able to understand and explain line graphs, scatter plots for two variables, relationships between a pair of variables using a scatter plot, trend lines, positive association, negative association, no association, and how to choose a data display. This is something that we start working on in early elementary. Even in kindergarten, they are asked to collect their own data and start making those graphs, reading those graphs, and that just grows every year after that as far as the kinds of graphs that they have to look at. So this is just the rest of the graphs in addition to what we did in the last lesson. Line graphs typically show a trend in a variable over time. They are usually marked with time on the horizontal axis and the variable being considered on the vertical axis. Consecutive data points are connected. So I feel like sometimes people get line graphs and scatter plots confused. Line graphs, if you look right here at this picture, we have this depiction of continuous data, and a line is drawn from one data point to the next. We can see on the x-axis we have time. On the y-axis we're looking at the weight over 10 years, and so that's the variable we're looking at. Everything else we've done so far has been discrete, which means it's not continuous data. We're not looking at it from year to year to year and connecting it. So if you have continuous data, you can depict it in a line graph. Scatter plots are used when we're looking at a relationship between variables. We don't do a line graph because it's going to have many points on it. There might be a trend, but it's not continuous in the fact that we can connect the points like we do on a line graph. And so it says sometimes a relationship between variables cannot be easily depicted by even a broken line, so a scatter plot may be used. Here we have many data points, and we see that there is a trend. It says this scatter plot shows the relation between the number of hours studied and the quiz scores. The highest score is a 10 and the lowest score is a 1. So when I look at this, it's obvious to read this graph and see that the more hours that the student studied, the quiz score was higher, and that depicts for us a positive relationship in the hours study and the score gained on the quiz, and that's what scatter plots can do for us. The trend line is what can be used to go through the data and closely fit the data as best it can. What we do is we use that line to make predictions, and so by the time we start using these in class, students have already learned about the equation of a line, considering the slope, the y-intercept, and so they can write that equation y equals mx plus b form, and what they can do is they can plug different hours into it to make a prediction about what the quiz score can be. That can only be done though if there is a relationship in the data. A positive association is when the data moves upward. So it says if the trend line slope is up from left to right, there is a positive association between the data on the horizontal axis and the vertical axis. An increase in the value of the variable on the horizontal axis would depict an increase on the variable on the vertical axis. So we saw that with the homework. The more time was spent studying, the higher that quiz score was, and so that gave us that positive trend. If we're looking at data where the points are going in a downward direction, that's going to give us a trend line with a negative slope. What people miss on this is it's still an increase on the x-axis. We're still going forward on the x-axis. So you see in this paragraph it says an increase in the value on the horizontal axis, but there's the decrease in the y values, which is making that come downward. And so if you think about, what would real life examples be? If I said I want to look at a relationship in the temperature outside and the number of hours the air conditioners ran in the house, well, if I think about that, the higher the temperature in the house, the more hours the air conditioner is going to be used, okay? If we think about that as far as the heater, we can kind of think about it this way. The higher the temperature on the x-axis, we would be using the heater less and less hours. And so you can make up tons of different examples where the data would be going in a downward spiral, and your students will be able to come up with many of those as well. Sometimes we look at variables that don't have any relationship between them at all. So you could have your students collect data on different things and try to see, okay, is there a relationship between variable A and variable B, or variable X and variable Y? It says if the points do not fall about any line, we say there is no association. No prediction can be made because there is no trend in that data. And that's kind of fun to have your students make up different examples of, okay, give me two variables that don't have any relationship at all, and therefore if we plotted them, the points would just be scattered everywhere. We also look at double line graphs. Double line graphs may be used together to demonstrate different sets of data where comparisons can be made. These are very useful if you are making comparisons. So this graph shows the crowdedness of housing from 1940 to 2000. One line showing crowded with more than one person per room, and the other line showing severely crowded with more than 1.5 persons per room. And so we can look at that comparison. It's really nice to do that on the same graph. We have the line graph, so that it is continuous data. The points are connected. Once again, on the line graph, you can see that the x-axis is time, and the y-axis depicts the variable that we're looking at. So it's the percents in this case. Last thing we talk about in this section is when we have our students collect data, after they collect it, you might ask them to display it in some way. When they choose that way to display it, they need to make sure they're picking an appropriate graph. You're not always going to use a circle graph. You're not always going to use a bar graph. And so there are techniques to teach them to make them, to help them make the appropriate choice. So they should use a bar graph if they are trying to compare numbers of data in a grouped category. And we looked at those in the previous lessons. They should use a histogram if they are trying to compare numbers, but they're grouped in numerical intervals. So like we did in the previous lesson where we're looking at, okay, how many were there between 30 and 39? How many were there between 40 and 49? When we have those numerical intervals, that's when it's best to use a histogram. A stem and leaf plot is used to show each value in the data set in intervals as well. And sometimes when we look at the data, there is a choice. You could say, okay, a stem and leaf would work, but a histogram would also work. Really, one is not better than the other in that case, so either one would work. But there are times when, based on the data, one graph would definitely be better than the others. Scatter plots we're going to use when we're looking at two variables, like, okay, grade on the quiz compared to time spent studying. Those are our two variables, and we're trying to see if there's a relationship between those. I can say, okay, number of ice cream cones sold and the temperature it is outside. We could see if there's a positive relationship there. We could graph that on a scatter plot to see that. A line graph is used to show how data changes over time, but it has to be continuous data if you're going to do a line graph. A circle graph is really good when we're showing division of a whole into parts. So if you say, okay, all of this makes 100%, and I want to show, okay, what percent each piece of this is, a circle graph is very good for that. And those are all the graphs that we looked at. Please do go and watch the video lecture. That's the only time I'm going to ask you to do that through the entire course. So if you'll do that, and then you'll be ready to finish your homework.